can start from team one.
Yeah. So in group one, we have Abhishek, Akhil, Charishma, and me, that is Ayush Bansal. So our topic is parts of a sounding rocket and types of material used to make the sounding rocket. So let me share my screen first. Hmm. Host, can you please enable the screen sharing?
Host.
Bhardeep.
Yeah. Got it. So we are using the Atharva's PDF that Atharva's design that he made. So I hope he don't have any problem.
नहीं ब्रो, मैं
So
कॉपीराइट
let's,
स्ट्राइक मार रहा हूँ.
okay, no problem, bro. So starting from the top, this, as you can see here, this is the design of a rocket, sounding rocket, as Atharva made it. And starting from top, we have this nose cone, okay, and then coming to the second part, as you can see here, the red part, it's in parachute shape. So it's a parachute, and this black part is a shock cord, okay, and this part is a canset. And here we have fuselage. Sorry, Abhishek, can you correct it? Okay,
Bro, that's avionics.
is it
Yeah, that's avionics.
Yeah.
okay? This part is avionics, and then move to the second part. We have a parachute to recover this two parts, the end one and this avionics part. And again we have shock cord which is attached to the that parachute and this part, rocket. And then we have this motor, and as you can see the side one, we have fins. Now starting from the nose cone, the material, it can be made of carbon, that fiber, or cardboard we can use to make it. And there are different shapes, or else, okay, yeah, here you go. So nose cone, we have different types of nose cone, but I'll prefer that sharp edged one because it will help in the drag, uh, like it will help to reach more height. So yeah, and yeah, this one is nose cone. And moving to the second part, that is parachute, we'll use two parachute here, or else we can use one. Okay, so in parachute, we can use nylon.
Ayush?
Give me a sec, please. Sorry guys, sorry. Mm, okay, yeah. So coming to the parachute, we can make it using nylon sheets, or like, yeah, the most preferable one material is nylon. And Bhargav,
Tell me.
can I show you your parachute that you made?
Yeah, you can, yeah.
Okay, thank you. Yes, sir.
आवाज आवाज कम कर दे.
Hey, it works.
ये क्या है भाई?
कम चलता तो
Okay,
है भाई.
no, actually, no. See, weight is less. Okay, we'll use more weight next time. So
अरे भाई किसके घर में चला
we'll
गया वो?
किसी के घर में घुसा वो.
वो घर नहीं था
okay,
वो
okay.
वो
So
ओके बता आयुष आयुष कंटिन्यू.
yeah, so that's the parachute. And why we are using that shock strings? No, because at the time when the recovery system will open, like the parachute will come out, there will a shock or more force will be on the rocket and the parachute on the strings. So the shock cord will absorb the shock and it will help in not tearing of the thread or shock cord or of tearing of that parachute. Okay, and we have now electronics part, that is sorry, CANSAT or avionics part. So yeah, and again we'll using this parachute and shock cord, and then coming to the motor part, we are using a motor and we have fins here.
Ayush, I have a
Yeah,
doubt.
yeah, please.
So
ask.
there are two parachutes, right? Like one is for the cancer and the other one is for the rocket motor
Nose.
of the engine, right?
Yeah, no, see, this wait, yeah, this parachute is for this the last, that is motor one, and this
For the cancer.
avionics part also. And yeah, no, avionic
For payload,
avionics
I'm
part.
telling one is for the payload,
Yeah.
one is for the.
There are there may be two parachutes for the rocket. There may be one parachute for the rocket. Depending
Yeah,
upon the size
it's
and what kind of shape you're building it, it depends on that कि कितना rockets you want to use. Also, the
Yeah.
two parachute recovery system is a different recovery system. There's a one parachute recovery system as well.
See, the thing is कि जो CANSAT पे जो parachute लगा है, it is that, I mean, essentially to recover the CANSAT, but also to deploy it. And the parachute in the back, which is right above the motor, it is the shock cord is connecting all the parts, which is the middle body and the end body, and then the parachute is recovering that parts.
Okay.
Yeah, so the parachute in front of the motor is essentially for the whole rocket. The one in the front is reserved specially for the CANSAT.
वही था.
okay. Thank you, Atharva. And the material that we use to make this, the whole body, we can use cardboard. Okay, and here Atharva has mentioned all the materials that we can use. Is here you can see that nose cone can be made of cardboard, or we can use the fiber, carbon fiber. Body tube can be made of PVC, that is polyvinyl chloride. And coming to the shock cord, that is nothing but elastic cords. And yeah, okay, bulkhead, that is again we can use cardboard to make it. And yeah, and let me show you fins. Okay, yeah, let me show you fins. Let me see here. Here you can see that fins. Okay, so we can use cardboard also to make the fins. And yeah, that's it. If Abhishek, Bhargav or Charishma wants to add anything, they can. Abhishek, Akhil or Charishma?
No, I have a question. Like, I think so. It may not be from the construction part. See, I don't know much about the rocket motors or the rocket engine there, but I've seen people using the Estes A series or C series or B series. So, is it should we also buy, or can we make it on our own? The
Motor.
Talking
Yeah.
about the motor, right?
yeah, that is yeah.
Yeah, the thing is ki, the motor we have its size specifications, and we have the how much output it should be giving also.
Yeah.
Yeah, so all we need to do is find a way to test our motor. So we'll make one with the size specifications,
Mm-hmm.
and then we need something to check if our filling technique is correct and the mixture which I've made is correct. That's it.
Okay.
We can make on our own.
Okay, that is just the propulsion, right? Like I mean,
Yeah.
yeah. Okay.
Okay.
Yeah.
So
Abhishek,
in the construction, in the materials or the parts, if Abhishek or Akhil or Charishma wants to add anything.
नहीं भाई कुछ नहीं.
Okay, So let me stop sharing.
Okay.
Is it fine?
Your part is done, right?
Yeah.
Hmm.
Okay. Team room 2, team 2.
भार्गव तू कर रहा है कि मैं करूँ? We both prepared documents essentially.
Yeah, I mean, you start over, like, share kar this
अच्छा,
screen.
see, our topic was just a second. Yeah, our topic was softwares used for designing rocket body and the simulations for it essentially. So rockets can be designed. Just a second, guys. Give me a second. Give me a second. Yeah, okay, sorry. The softwares there's multiple softwares out there, but till date the best ones and the most simplest ones to use have been SpaceCAD and Open Rockets. Okay, just because you saw the rocket design which I made previously, that was made from Open Rockets. So it gives you freedom to add and modify specific components, mirror those components, because the placing the fins would have been a pain if that option wasn't available. Same with the launch lugs also. So that is done very well by Open Rockets. Best part about it, it's an open source software, so you don't have to pay. Apart from that, it gives you the center of gravity, center of pressure, all of the good stuff. And it also, just how we showed, it also shows you the individual components ka mass and their density. Yeah, just a second. Yeah. So it also shows you the individual components I mean, what it's made of, what its shape is, its inside and outside diameter, and its individual mass. And it, in the end, it also gives you, with the flight simulation data, it also gives you its altitude, flight time, apogee time, and optimum delay time. Optimum delay time is at the point where we'll deploy the CANSAT. Now, this flight time is given specifically for this motor. So you have that freedom of selecting your motor and running multiple simulations on it. So this I-class motor we have been running simulation on, and that's how it gives you a graph essentially of how how your rocket's gonna go. See, this is your graph. So the red line shows your altitude and blue is your vertical velocity. At this point, that's the apogee. After that, your vertical velocity starts decreasing, and that's your flight path. I mean, your vertical acceleration. It goes like that. So till here, it's the apogee. Here it stops, and then suddenly it spikes and starts falling down. That's what it is. So this has all been done using Open Rocket. So that's another simulation software. Apart from that, for fluid dynamics of our rocket, we can use Autodesk Fluid Dynamics, which computation fluid dynamics, which can give you the individual stress strain graph of the rocket. So we know if we are working apart too much or if there's too much stress on the rocket.
Okay.
Yeah. Guys, any questions?
Feel free to ask.
Acha, if there is nothing, Bhargav.
Yeah, I don't have anything to add. Atharva like actually covered everything, and it is not only we have Open Rocket, we have many other softwares also, something like Roxim or
Roxim.
AeroCAD or something like SpaceCAD. All these are there, but since Open Rocket is much more available and open source, something that's versatile. So that's why we are using that. That's it.
Okay. So different materials and size and everything will affect the drag and then altitude, CG, CP and all. So to explain the one of the two things I think is really important is CG and CP and how it actually matters in a rocket. All right. So group 3 will explain about CG and CP. I hope group 2 is done. Just a minute. Group 2 is done, right?
हाँ bro, हो गया.
Okay. Group 3, you can continue.
Yeah. So as Paradeep told that CG and CP are two important points. Yes, they are important in the matter of the stability of the rocket. So my team and I have just prepared something based on that. So starting off with center of gravity. It's basically the point at which the total weight of the body is thought to be concentrated. Um, it's just an imaginary point. It's not that it's a fixed point in the body. It's something that we are assuming or we are imagining. So as you all know, like when the rocket flies in the air, it both moves forward at the same time it rotates. So it has both translation motion and rotational motion. So this rotation occurs at the point which is the center of gravity. Now, there are a couple of methods to find out the center of gravity. It's basically the first one. There are mathematical methods, but right now going through the mechanical methods are the easy ones just for the time being, where we approximately get the position of the center of gravity of the body. And this is one of the way. It's basically that we just balance. First, we just cut out a cardboard, in the shape of a rocket. The size doesn't matter, but then the shape and the scale should be the perfect one. So the thing is that we can just, have a rod or something and balance this cardboard piece there. So basically at the point where this cardboard cutout of our rocket balances completely, that point is taken to be as a center of gravity. To cross verify it, what we can do is that we can tie up the rocket or a model of the rocket using a thread and just hang it from a point, and the point at which where or the entire rocket stays exactly in the proper plane, that place would be that point would be taken as a center of gravity. um Now coming to the center of pressure, um, basically center of pressure of the rocket is a point at which the air pressure forces of the rocket seem to be concentrated. So this means that when the rocket is flying in the air, obviously there's atmospheric forces acting on it, and these forces act on the surface of the rocket with different pressures applying on the surface. So those forces are taken to be the aerodynamic forces, and as it acts on all the parts of the rocket, we just assume one point on the entire body of the rocket to be the center of pressure. That means where we assume all these forces are to be concentrated and equally represented on the other surfaces of the rocket. Um, Basically, just like the center of gravity, the center of pressure can also be calculated mathematically. It uses integration, but we have other mechanical methods, which is kind of similar to the center of gravity. That's basically that we cut out a profile of a rocket in a cardboard, just as that. It doesn't have to be of the same size, but it has to be the same shape and a proper scale. At the same way, we just try balancing it on a edge of a ruler, and this spot, like wherever it balances, it marks the center of pressure. There are different other methods too, but this is a most mechanical and easy way of finding it out. And this for the center of gravity, where we just hang it up. That's it.
So, Ananya,
Yeah.
don't you think that mathematically find the CG is easier than to find mechanically? Because we have to do some hit and trial methods
obviously.
We can
in
also find
mechanical
this by
also.
stimulation.
Yeah, that's there, Ayush. But see, if you just date back to a few hours before, when in the AEC class, ma'am made us solve the question as well as asked us to do it graphically.
Yeah.
It's just one of the methods of finding the answer. It doesn't mean that it is the actual answer. Mathematically, we find the actual answer, but then to just reach our actual answer, we can use a mechanical method, which will give us a proper range of where could our CG or CP be located on the part of the body. Sorry, on the body of the rocket.
And
So
mathematically,
it is just
actually,
an
if you
approximation.
make, just a point to be added, mathematically, if you make some mistake in one of the values, then what will happen is that the CP will completely change. All right. But this method, actually, yes, you won't get the perfect value, but you'll definitely get a value which will be correct. Okay. Because you're balancing it out, right? So if it's not balancing, then you're not getting the correct value. Okay, but if it's balanced, that means you're getting somewhere near to that value. and then you can cross check with mathematical calculations, and obviously nowadays we have simulations, so we don't have to do that much, but
Yeah.
मैं बस एक पॉइंट ऐड करना चाहूंगा, ये जो सीजी वाला वैल्यू है ये बस छोटे रॉकेट्स के लिए, लाइक फॉर C2 मतलब मिड पावर्ड रॉकेटरी के लिए है. हाई पावर्ड रॉकेटरी के लिए ये हम यूज नहीं कर सकते क्योंकि बॉडी साइज ज्यादा बड़ा रहता है, सो वी नीड टू डू इट बाय स्टिमुलेशन और फिर क्या बोलते हैं एज आयुष सेड मैथमेटिकली. अथर्वा भी शायद से एग्री करना चाहिए, पता नहीं उसका थॉट्स है.
नहीं, the thing is कि if we have the final positioning वगैरह अच्छे से, at this point, see, I just shared the same thing. The PDF which I have sent, it is not the final rocket, but in that they have mentioned the center of gravity and the center of pressure also. The blue dot which you guys see is the center of gravity, and which has already been calculated at 47.4 centimeters at the rocket's length, across the rocket's length. So that has already been done for us. All we need now is a proper, I mean,
बस उसको फ्रेम करना है, यू नो.
हाँ.
ये वाला जो CPCG है मतलब वो वाला ओल्ड टेक्निक था, मतलब कि कैसे पहले सॉफ्टवेयर वगैरह नहीं थे और मैथमेटिकली टाइम लगता था, तो that was done
right now
before.
all we have to do is put in the values and construct the rocket, and we'll have it for us in front of
It's
us.
much more advanced now, that's all.
हाँ, तो हम भी हाई पावर्ड ही कर रहे हैं ना.
मैं एडवांस बोल रहा हूँ कि मतलब सिमुलेशन आ गया है, तो मैथमेटिकली इंटीग्रेट नहीं करना है हमें, सिमुलेट कर देगा.
हाँ, मैथमेटिकली करना नहीं है, लेकिन जब भी तू अगर पेपर प्रेजेंट करेगा तो तेरे को मैथमेटिकली करके
दिखाना पड़ेगा. फॉर दैट वी हैव टू शो. Okay, anything anyone wants to ask, please do, because construction is something really new to everyone. Next topic is rather easy, so I'm not worried about that. But
ये वाला कौन सा था? बस कंस्ट्रक्शन था क्या?
हाँ, ये कंस्ट्रक्शन था. So see, the new topic
तो
that you guys,
कौन लीड कर रहा था ये वाला?
कोई लीड नहीं कर रहा है so far. टीम्स बने
अरे
नहीं.
भाई ग्रुप में कौन था, मतलब ब्रेकआउट रूम में?
3 ब्रेकआउट रूम थे, तीनों के तीनों कंस्ट्रक्शन के ऊपर ही बोल रहे थे.
नहीं, मतलब तू अभी बोला मतलब कंस्ट्रक्शन पार्ट का तू बात कर रहा था ना.
हाँ,
तो ये CPCG तो उसी में है ना, मतलब कैसे
तो
कंस्ट्रक्ट.
हाँ, CPCG अनन्या, सुकिता, वैशाली और शिवा थे. एंड पार्ट ऑफ, हाँ, तो yeah, this part is done. Please guys, if you have any questions, पूछ लो.
कंस्ट्रक्शन कौन हैंडल कर रहा है, मतलब कैसे बनाना है वो कौन हैंडल कर रहा है?
ये हुआ नहीं है टीमों में.
Fabrication की